This is our 9-1 to 9-4 review. Calculators are not allowed, and this is number 6, which is the free response. So if we read this, we are given a cylindrical corn silo, and we've got corn coming into the silo at a rate of 3 pi times root 6h cubic feet per hour. And we're given the formula for the volume of that cylinder, and based on the information that is given to us, we now want to show that the rate at which the height is changing is equal to this root 6h over 3. So what we're going to be looking for when we grade this is whether or not you can interpret the words here. Remember, one of our skills all throughout this chapter is to be able to translate words into mathematical statements. So what I see in here is the volume V is changing at a rate of. So I just told you in this sentence that dV dt is equal to 3 pi times a root 6h. And if we look at what they're asking us for, they want us to show what the rate of change is for the height. So the only way we're going to get here is if we can somehow relate the dH dt to a dV dt. So here's a dV dt. It doesn't have a dH dt involved, but up here I was told the relationship between V and H. So I can write down the volume is a pi times the radius squared times the height. And if we look carefully at the picture, we can see that over time that radius is not changing at all. It is always 3. So we can write that as a 9 pi h. So if I take the derivative of this statement, I'll get a dV dt, move through the constant and hit that h, and it'll become a dH dt. So now I have two expressions for dV dt, and because they are both dV dt's, they should equal each other. So that means this 3 pi times a root 6h needs to equal a 9 pi times a dH dt. So I can write that here. And the goal is to isolate dH dt. So if I isolate dH dt, I will get a 3 pi times a root 6h divided by a 9 pi. Reduce that, you end up exactly where we're supposed to, and we get a root 6h over a 3, and we're done. So now we're ready to do part B. Part B says we're now going to solve this differential equation, and we're going to do it by separating the variables. And if we read the problem, we want to end up with h being a function of t. That means we want to move as little as possible over to the h side. And I'm going to tell you, a lot of people make errors with that root 6. They move it and then they forget to do chain rule, or they move it and they move it incorrectly. So to avoid errors, and this is a little different than the key that I have on your answer sheet, but it'll work both ways. You just have to be careful with that root 6. So I'm going to do it this time by just moving the root h, and I'm going to leave the root 6 over there. So now when I integrate both sides, I need to treat that as an h to a negative 1/2. And this is just going to be a constant. So the antiderivative of this says I need to add 1 to that power and then divide by the new power. So dividing by 1/2 is the same as multiplying by 2. And over here I'll just have a root 6 over 3 times a t plus a constant. So because time is 0, I could, that might be a little tricky, so I'm going to isolate the h first before I try and solve for that c. So to isolate the h, I need to divide by a 2. And notice if I take a random constant and divide it by 2, it's still a random constant. It's just a different random constant than it was before. But until I plug in my point, I don't nail that constant down. So I haven't plugged in my point yet, so I can just change the subscript, and then I can square both sides. So here's another place where people make mistakes. They want to square and then distribute, and that doesn't work. Remember, when you're squaring a binomial, you'd have to write it twice and then FOIL everything out. takes a lot of time and it doesn't make it look any better, so I would just leave it like this. Now we have h alone, so we're ready to plug in our point. We know when time was 0, h turned out to be 5. So I can plug in my 5 for h and 0 for my time, and I can figure out that that c sub 2 is the square root of 5. So if I now plug that in, I get a root 6 over 6 times a t plus a root 5 quantity squared, and I'm done. Now you'll notice that I had the root 6 on the bottom on my answer key, but this is equivalent, so if you do it this way on the test and you end up with an equivalent expression, you're still going to get full points. Last part C says, at what time is the corn silo full if the height of the silo is 20 feet? Well, that means my h is going to be 20, and it's asking me for what time it is. So I take this expression, and I get 20 equals a root 6 over 6 times a t plus a root 5, and it's squared. So if I want to isolate the t, I need to take the square root. Notice we're taking the square root of a height, and we're finding time, so everything's going to be positive. So I'll get a 2 root 5 on the left, and I'll get a root 6 over 6t plus a root 5 on the right. So subtract the root 5, multiply by a 6, and divide by a root 6. This would be correct, or you could do a root 6 over a root 6 to rationalize that denominator, and you'll end up with the answer that I have, which is t equals root 30 hours.